is that's the name of a single photograph taken by that telescope, which for me is more profound than any picture from the Apollo era. More so than Spaceship Earth, Earthrise, even more so than the beautiful and richly detailed images of the planets in our solar system. The Hubble Deep Field, let me tell you what that is. First of all, if you want observing time on the Hubble telescope, what you have to do is apply. You write up a proposal and you apply. And about anywhere between 2 and 10 times more requests for time are submitted than are allocated. So it's oversubscribed, it's simply called. It's an oversubscribed telescope, as are most good telescopes. Now, what do I say? I say, I want to look at this object because I think it's interesting for these reasons, and you go on and on and on and on and on. And a committee reviews it. Oh, we agree that's a good object, give them time. But suppose I wrote in a proposal and say, I want to pick a part of the sky completely randomly. And I want to blow 10 days of exposures on that one spot on the sky and just see what comes up. It would be laughed out of the room because there's so many other worthy proposals. People wanting to discover the nature of quasars or black holes or the spectra of gas clouds in the universe. So what this took is something called director's discretionary time. The director of every observatory, including the director of the Hubble telescope, has time that he or she can allocate on a whim. Doesn't have to go through peer review, they can just assign it according to their discretion. Maybe someone, if it's ground-based, was clouded out on one of their observing runs, and they have a special interest in that project. They give them some extra time just so that maybe it's a student who needed the time for the thesis. That's typically how the discretionary time gets allocated. This particular case, the director said, I'm going to take 10 days consecutively of the observing time of this telescope. And I'm going to select a completely random but especially boring part of the night sky. How boring is it? I don't want any bright stars there. I want it to be away from the plane of the Milky Way galaxy because the plane is very thick with dust and gas and things that would obscure your view. I want to pick a part in the sky where Earth doesn't get in the way because Hubble telescope is orbiting very close to the surface of the Earth. And as Hubble telescope orbits Earth, there are actually some directions it can look. Where Earth, no matter where it is around the Earth, it can always look into that direction. So it found a spot, continuously visible. Avoid clusters of galaxies that we already know about, because we won't be learning anything. Just find the most uninteresting part of the sky you possibly can. And they did. It's a little swatch of sky near what happens to be the Big Dipper in the northern cap. Here's the North Pole of the Earth. The Big Dipper on any given night is tracing circles around the North Star. A continuously visible zone. The Hubble telescope found that one spot, took 342 consecutive exposures of the identical scene. You take all those exposures, then you add them together to make one image. Very high quality image. The amount of time allocated to this photo was larger than any other observing project ever granted by the Hubble telescope. You know how much of the sky this image represents? The field of view of the Hubble is not that large. It's not that large. And this particular picture was 1/100th the area of the full moon on the sky. 1/100th the area. Now, to give you an idea of that, take a penny. Take a penny and hold it at arm's length and ask yourself, how big is the size of Abe Lincoln's eyeball? That is the size of the patch on the sky represented by the Hubble Deep Field. Let's take a look at that image. Here it is. That is the Hubble Deep Field. One of the most boring parts of the night sky. And what does it reveal? Thousands of galaxies. Practically every splotch of light in that image is an entire galaxy, not much unlike our own Milky Way, bearing hundreds of billions of stars each. What's extraordinary about this image is, given the precision of Hubble's imagery, you can get close to the picture and look in on the galaxy. I've seen pictures sort of like this before, taken by ground-based telescopes, and it's got just as many galaxies, but they're just all smudges. They're just smudges, and I look at it and say, okay, you get a little closer to the smudge, it's just, I'm closer to a smudge. Here, as I look real close, I can see structure, I see spiral arms, I see regions of extra star formation, I see different colors. Some galaxies are larger, they're likely closer. Other galaxies are smaller, they're likely farther away. Where does it get the colors? Why are some galaxies blue? Some stars are blue. Those galaxies are highly represented in that species of star. How about the red galaxies? Some stars are red. Some stars are white. We have red, white, and blue, and everything in between. Remember, this is the size of Abe Lincoln's eyeball on a penny held at arm's distance, projected on the background sky. So this is not simply a picture of something flat. It is a beam through the universe, looking at nearby things as well as objects that are the most distant, all compiled into one image. The farthest known galaxy in all the catalogs is in this picture. It's a red dot. Wait, how did it turn red? Well, there's this expanding universe effect. We're in an expanding universe, and light from galaxies, the wavelength of the light in an expanding universe gets stretched. If you stretch light, you give it lower and lower energy, and red light has less energy than blue light. So if you start out a blue galaxy and you're very far away in this expanding universe, receding quickly, your blue colors become red. And so the farthest galaxy in this picture is actually red. Let's see if we... Right there. We zoomed in on a little piece of the Hubble Deep Field, and that little red thing in the center there, that galaxy, we see that not as it is, but as it once was, nearly 13 billion years ago. That galaxy is one of the earliest galaxies known. Its light has been traveling for 13 billion years to reach us. And it represents it's a signpost for what the universe was like in the distant past. Once again, you can see every other smudge there is a galaxy, and just to the right of our red smudge is you see structure in another spiral galaxy very distant.